Hi folks, we're going to look at 10a from part B of the Unit 3 assignment. So they give us this function and they tell us that the slope of the tangent is 0 when x is equal to 2/3. And they want us to use this information to find k. All right, so since they're giving us information about the slope of the tangent, we're going to be working with the derivative. So we'll start by taking the derivative of this function. Okay, so we'll have to use the product rule in the first part. So derivative of x squared is 2x times the second function, e to the kx, okay, plus first function x squared times the derivative of e to the kx. So here, this is going to be like our u. So derivative of e to the u is just e to the u. So e to the kx. Okay, and now we have to take the derivative of u. So derivative of kx, well, k is just a constant times the derivative of x is 1. So we just have k. Okay, and we know that this is going to be equal, and the derivative of p, which is just a constant, is going to be 0. All right, so they're telling us that the derivative is 0 when x is equal to 2/3. So I'm just going to replace 2/3 for x here. So 2 times 2/3 times e to the k times 2/3, plus this is going to be 2/3 squared times again e times k to the 2/3, all right, times k. All right, and now we can just solve for k. Okay, so first thing I'm going to do is I see that there's a common factor of e to the 2/3 k, so I'll take that out. And I also see some other common factors. So let me simplify it first. Write it out just to make sure I don't make a mistake. So here we've got 4/3 e to the 2/3 k plus, and here what do we have? We have 4/9, okay, times k times e to the 2/3 k. All right, so let's factor out as much as we can. So here I see that there's a 4 in the numerator and a 3 in the denominator that I can factor out, so 4/3. Okay, and then the e to the 2/3 k. And let's see what we're left with here. Well, we've removed all the factors, so we're just left with 1. And then here, plus, well, we've removed the factor of 4 in the numerator, but only a factor of 3 in the denominator. So we have 1/3. We still have the k, and we've removed the e to the 2/3 k. Okay, and now we can solve this quite nicely because it's in factored form. 4/3 obviously not equal to 0. E to the 2/3 k can never be equal to 0. So the only thing we have left is that 1 plus 1/3 k is equal to 0. And now we can solve this. So 1/3 k is equal to -1. So k is equal to 3 times -1, -3. And there's our answer. Okay. So again, here all we did was we used the information given in order to solve for particular parameters. So in this case here, they gave us information about the slope of the tangent at a particular point, which is why I worked with the derivative. Now, in taking the derivative, the parameter p disappeared, so I didn't have to worry about that. So the only thing I was left with, once I inputted my x value and the value of my derivative, I could then solve for the k value. And again, I want to bring your attention here to a trick now we've used quite often, this idea of looking for common factors when factoring an expression. Okay, that's it for this one.